Good evening, everyone. My name is Uma Maheshwari. I am here to tell about the microcontroller application and advanced processor in the topic of advanced RISC machine, that is also called as an ARM. Here, before we are just going into an ARM, what is ARM, everything, we just see what is the reference model of that ARM. In that, we will be having a 7 layers, that is the same like your computer networks. Okay, so the application layer, service application protocols, and the network layer, device one, and then security one, and then management, everything. So this ARM architecture, that is this um, arch the reference model, this is a reference model. It is a one which is a framework which is also used to design and build to in portable systems, like in a particular manner, like it is a context of an internet, and it is also like an IoT base only. It also acts as a blueprint. Okay, blueprint. So the architecture, by identifying the common components, and it is also an interconnected with the one, the what is ARM actually? What it aims to promote one is like it is also an IoT domain manner only, and it is also facilitate the development of a system and to work together. So, I mean, like sensors, all the things. So working together means what are all the things it will come, like sensors it will come, and sensors means it will just interfacing with some other thing. So that particular microcontroller it is also will come, and is also like you will be getting a microprocessor or controller, and then you will be getting a cloud computing one. These are all the combined one is called as an ARM reference model. Here, what are all the blocks which has been involved in this? The building blocks are, it identifies the common components like building blocks that is also used to construct various IoT architectures. So the common understanding, what is the common understanding in this one is, it provides a shared vocabulary and an understanding of the IoT domain. IoT domain is a vast one, that is where you cannot just, it is like you just can't able to retrieve what is there inside it. So making it is also easier to for different stakeholders and to collaborate all the things. And interconnection, so the IoT model is also called as a like ARM, I told, like the ARM identifies the common components like building blocks that is also there, and it also shows how these components can be connected together to meet the needs of a different application areas. So the foundation for design is like the ARM is also a starting point for designing is such a specific task, that is an IoT system. It is allows the developers to build a well-defined and interpolation foundation. Okay, so from the next slide, from this slide we can see elaborately what is ARM. So this LPC2148, so much of ARM architecture, so much of ARM processors are there. In this, we'll be just concentrating in this LPC2148. In this, you will be having like 2x16 LCD displays, and then DAC output, 4x4 matrix keypad. This matrix keypad is, you are just coming from 8085, 86, and then PIC microcontroller, everywhere it is there. And then RS232. What is this RS232? It is being used for a recommended standard 232 is called as an RS232. So this is also connected to your system. If you want to just connect to any serial connection means you will be using this RS232. The buzzer alarm is there, and then I2C, RTC, ITC, I2C, and then RTC is nothing but your integrated circuit, and then RTC is nothing but you will be getting a what is that protocol. So these are all the protocols which has been used by using this ARM architecture. And then you will be having input and then JTAG port, everything else. And here in this one, this LPC2148 is a single chip, that is how many bits you can handle. It can handle up to 16 or 32 bit RISC architecture. What is RISC? This is not an RISC RISC, this is called as RISC RISC, so that is reduced instruction set computing. In this microcontroller with the 512 of KB on chip flash RAM with in system, ISP is nothing but called as in system programming model. and you will be getting two 10 bit ADC with 14 channels, and then speed device controller, and two UART, one with full-time modem architecture interface. This ARM processor was also used extensively in consumer electronics devices such as smartphones, tablets, everything. So the microprocessor, it is also consists of only a central processing unit, whereas the microcontroller contains a CPU, CPU personal computer with here in this case the microcontroller consists only a central processing unit, whereas the microcontroller contains a CPU, memory, and all input and output, all integrated into one chip. Here the next one is how this LPC2148 works. This is called as LPC2148. This is from NXP. LPC2148 is an ARM7 TDMIS based microcontroller with the features like on-chip flash memory, RAM, static RAM, USB 2.0, serial interface, ADCs, DACs, timers, everything, etc. Everything it is there. The RISC-based design, first one is the features are called as the RISC-based design, 32-bit, 64-bit architecture, and this is also called as a pipeline architecture is also there in this LPC2148, and it can conditional execution is also there, and then power efficiency is also there in the case of LPC2148, and the scalability and flexibility is also there. Say for example, the next one is the features of ARM. In these features, what you will be having like a built-in memory, real-time clock RTC support. It is a versatile timers, counters, power saving modes, and efficient power consumption here. Here in this one, the task scheduling is the more important one. What is the task scheduling? In this RTOS, RTOS means real-time operating system. It provides a mechanism for managing multiple tasks or multiple threads, we can say. In some other software languages, we can say that is also threads. It run concurrently. It is a crucial one when different parts of a application need to be executed at a specific time. Say for example, each and every one is being executed in some particular manner. So for that specific time it has been used. So it is also called as an inter-task communication and resource management, flexibility and scalability. It is also there in the case of features. We'll see about the applications of LPC2148. In this application, in general, you will be getting the robotics and then industrial control. Of course, it has been used for robotics. In the previous slide itself, we have seen. And the embedded system development, it has been in a multi application. It has been used, so it has been used in an embedded system. Data acquisition and then processing, and then home automation, and then consumer electronics. In this and all, it has been used. And RTOS application for LPC218, this specific picture is one used for, it is used in calculators. That is what I have used this slide for better understanding. For robotics arm, the point which has been just points to that particular thing is called as a step. It has been used for a calculators, and then stepper motors, industrial monitoring, automated systems, everything. This is a small classroom activity. The assessment questions are: what is the standard form of ARM, and how many registers does ARM have, and how many operating modes does ARM have, and what the processor is executing in ARM state. Then all the instructions are how much of bits wide. What is the standard form of LSL? We'll see the next topic in the next video. Thank you.